Algebra 1 skills number 43, compound interests. So we have a formula for this. And this formula is given on a lot of formula sheets. And you see there's lots of variables in this formula. P is the principal, which is the current original amount. So when you're studying exponentials, you know that whatever's in this position is your starting amount. So we just happen to call that principal when we're dealing with interest problems. N is the number of compoundings per year, and we have a table for that in just a moment. R is the rate of interest, which again you want to present as a decimal right here. So for example, if it's 2%, you'll put 0.02 in this position, and T is time. This A would be the amount after a certain amount of time has gone by with a certain percentage and certain number of compoundings. Now, as far as your N values, the most common is monthly. Of course, there's 12 months in a year. Quarterly, there's 4 quarters in anything, including years. Semi-annually, semi means half, so half a year, that's 2 times per year, and annually would be 1 time per year. Okay, so here's an example. How much money will an investor have if he deposits $20,000 into an account that draws 6.5% interest, compounding quarterly over 10 years? Okay, so here's your formula, and again, we're going to load all of our values here. 20,000 is how much was invested. This 1 is in the formula. It's the 100% you start with and add to. Interest is always adding, by the way, for your exponential models. This is your interest rate presented as a decimal. Remember here, 2 places to the left. Quarterly means that N is 4. Now, N makes 2 appearances in the formula on the bottom and here. And then the number of years would be 10 right there. Okay, so you just simply type that in, and you get 38,000 plus dollars there. So what this is again is you put the money in, the bank uses your money, therefore they pay you interest for that fee of using your money. And as you can see, over the course of 10 years, he almost doubled his money. A second example, how much money will a woman have if she deposits $15.50 into an account that draws 2% interest compounded monthly over 4 years? So very similar. Again, we're going to load our values in. So you might want to look at those values, see if you understand where each value comes from. I will note that monthly would be 12 in these 2 positions. Remember, that's your N. Otherwise, it's pretty straightforward. The R is 0.02. The number of years is 4. Your principal is $15.50. And again, she doesn't make a whole lot of money here because it's a relatively low interest rate over a course of relatively a small amount of time. But regardless, you should end up with more money than what you started with. Now, we can put a wrinkle here, several wrinkles if you want to. We're going to just put one on this one. Jeff wants to have $10,000 in his account in 5 years. Okay, he wants to have it, which means he doesn't have it yet. How much should he put into his account? Well, this time P is the variable. We don't know how much to start with. We know how much he wants to have, but how much should he start with? Notice semi-annually would be the 2 in this position. Okay, so when you work this out, what I would recommend here, I wrote 1.149 just for demonstration purposes, but when you're working with large numbers, a rounding error can make a significant difference. So I would leave this number on my calculator screen if I'm doing this. I don't actually divide 10,000 by 1.149. I divide 10,000 by all of that decimal. I'm just putting part of it on there just to demonstrate. But I would divide here, and in so doing, you end up with $8,702.02. Money should most always be rounded to 2 decimal places. That's how money works. We round to the nearest penny. Also note here that it should make sense that we start with less than 10,000. Remember, 10,000 is what he had after the investment. Therefore, he started with an amount less than that. So compound interest.